We're going to go through number 17 from section 7.5, linear programming. If you don't have your book with you, please go ahead and stop the video and grab it and turn to page 461 so that you'll be able to follow along. In addition, make sure that you have a notebook and something to write with so that you can jot down any important information that we come across as we read through the narrative. So number 17 reads, a theater is presenting a program on drinking and driving for students and their parents. Proceeds will be donated to a local alcohol information center. Admission is $2 for parents and $1 for students. However, the situation has two constraints. The theater can hold no more than 150 people, and every two parents must bring at least one student. How many parents and students should attend to raise the maximum amount of money? So one of the first things we can go ahead and do is identify the variables that we're going to work with. So say, for example, we use P and S. So P would represent the number of parents, and S will represent the number of students. This is what we will initially need to create our objective function. The objective of this problem is to find out how many parents and students we will need in order to generate the most amount of money so that we can donate that to the center. Obviously, the more money we make, the better off the center will be, so that's going to be our objective or our goal. So we know that we want to write this with respect to money. So I know that for parents, I'm going to charge them $2 per parent. And for students, I'm going to charge them $1. And for now, I'm going to have this function equal z. I don't know what the maximum amount of money will be that I'm going to bring in, and I also don't know how many parents and students I could potentially get in to figure out that maximum. So I'm going to leave this as 2 times p plus 1 times s is equal to z. So note that we also run into some constraints or restrictions. One of the first ones, it reads that the theater can hold no more than 150 people. This shouldn't really come as a surprise because most buildings nowadays, I would say, you probably see some sort of sign indicating maximum occupancy for safety reasons. So we know that whatever it is, the number of parents plus the number of students has to be less than or equal to 150. I can't throw more people in there because I would run out of seats, or if you wanted to get really realistic, I would violate some safety laws. The second part, or the second constraint, is a little bit trickier. So the second constraint reads that every two parents must bring in at least one student. So in other words, with our we need to set up a ratio here. So I'm going to kind of work in some blue ink at the lower left-hand corner. I can create a ratio of students to parents. In other words, I'm going to create a ratio of S over P. And I want this ratio to be at least one student per two parents. In other words, the word at least indicates that I want to work with a greater than or equal to sign. Because, for example, if I say that you can have at least 3 cookies, that means that you can have 3, but then you can actually go further. If it's still a little foggy, compare it to using the opposite of at least, which is at most. If I tell you you can have at most 3 cookies, that means that you have a cap. After 3 cookies, you're cut off. With at least, you will have your 3, and then you can have a little bit more. So I know that the ratio that I'm going to experience here is 1 student per 2 parents. I can do a little bit of work here and maybe bring this to something a little bit more familiar. So what I'm going to go ahead and do is I'm going to cross multiply. So this will give us 2 times s is greater than or equal to p times 1, or just p. And then we will divide both sides by 2 to get the constraint s is greater than p over 2. So I'm going to go ahead and add that to my list. S is greater than or equal to p over 2. How you want to read that, you're basically saying that the number of students has to be greater than or equal to one half the number of parents. So one parent cannot just show up, well, actually 1 over 1 is greater than 1/2. So in other words, you can't have a group of 5 parents come up to purchase tickets but only bring one child between all 5 of them, because that would be a ratio of 1 student to 5 parents. If you were to type that into your calculator, that would come out to 2/10 or 20%, which is going to be much less than 1 over 2 or 1/2 or 5/10 or 50%. So these are the 2 constraints. You can also expand this idea, and you can say that the number of parents has to be greater than or equal to 0. And you also can say that the number of students has to be greater than or equal to 0. It doesn't make sense to say that you can have negative students or negative parents attend. So this basically is just informing us that we are going to be working in the first quadrant. So I'm just going to go ahead and sketch in the first quadrant here. And because we're working with such a large number in our first constraint, that p plus s is less than or equal to 150, I'm going to go ahead and do my tick marks on a scale of 10. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and 150. And again, the same thing over here. You all might have better luck with by doing this by hand. The stylus pen can be a little bit tricky sometimes. Okay, y-axis, x-axis, just labeling those for good measure. Oops, sorry. And actually, that's a little bit of a mistake. We're not using x and y variables, so I'm going to go ahead and say that, and this is completely arbitrary, but I'm going to say that instead of my y-axis, I'm going to make this my s, and instead of x, I'm going to make that my p. Okay, I guess it's kind of a happy error because it opens up a good discussion point. So notice I could have used x and y and that would have made everything consistent. I decided to use p and s. So the main thing that you want to know here is if you start working with variables other than x and y and you are graphing them, just make sure that you kind of designate which axis will represent one variable and which axis will represent the other. It would not have been it would not have caused a problem if you had labeled the vertical axis P and the horizontal axis S. I just decided to label them the way that I did. So the first thing that I'm going to do is I'm going to go ahead and graph the first line in orange so that P plus S is less than or equal to 50. You can get this into slope-intercept form if you wish. You can also graph this pretty easily by looking at the intercepts. So if I were to plug in 0 for P, then I would have S is equal to 150. So I'm just going to actually evaluate these as if they have an equal sign in them. So if I put 0 in for P then I have s is equal to 150. So one of my points will be at 0, 150. I can do the same thing and then do put 0 in for s. Then I would get p is equal to 150. So then that means that I have another point at 150 and 0. Oops. There we go. So I'm going to connect those 2 points together. And then I need to decide which way I'm going to shade. And if you think about it, if I were to say pick the origin, then I would have 0 plus 0 is less than or equal to 50. So again, if I plug that in and check, so all of my shading is going to happen on this side of the line. Okay, so the next one that we can check is going to be s is greater than or equal to p over 2. Again, if I put in, we'll go ahead and do some work here. If we do s is greater than or equal to p over 2, if I put 0 in for p, then I will get s is equal to 0. So I would have 1 point at the origin, 0, 0. Okay. Then if I were to continue this work, and I'll do it on the lower part of the screen, let's say I pick, let's work with 20. And the reason why I'm going to work with 20 here is because 20 will divide, will be easily divided by 2. So we'll get s is equal to 10, so we'll have a point at 20 and 10. And I'm going to continue on in this fashion, just using other values that are easily divided by 2. Maybe I'll skip and just pick 80. That'll help me move along faster. And perhaps you're even seeing a pattern as I'm doing this. It looks like whatever p value I pick, the s value will be half of it. Okay, so we will connect those points. And then we need to decide which way to shade. So this time I cannot use the origin as a checkpoint because the line is using it. So let's say I pick, let's test point, I don't know, 0, 20. So I will put 20 in for s, 0 in for 2. Is 20 greater than or equal to 0? Yes. So this is telling me to shade on this side. So now I need to know where I need to focus. And I'm going to go ahead and highlight that in pink. Like the areas that I need to work with are going to be where the shading overlaps. So it's going to be contained in this pink triangle. Points that create that triangle are going to be at point 0, 150. Then you have another point at 0, 0. And then you also have a point at, what is that one? At 150. So we need to decide which one is going to bring us the most amount of money. So in the first case, now we're going to go into our objective function. So I'm going to, I've circled it in pink, and I will go ahead and do the check work in pink. So basically I'm saying if I don't have any parents attend, but I have 150 students attend, that's going to result in bringing in $150. Maybe that's good. I can guarantee you that if we use the origin, that means that no parents come and no students come. Well, that's going to give us a whopping profit of $0. So that's probably not going to be your answer for the maximum amount of money that you can bring in. So now the third option would be if 100 parents came and 50 students came. So that means that we would pull in $200 from the parents, $50 from the students, to make a grand total of $250. This is the max amount of money that we can bring in and then donate to the center. So this is your solution. I hope this explanation was clear and helped clear everything out. If you have any additional questions, please let me know, and thank you very much.